Hello, everyone. My name is Jonathan, and welcome to Ventev Connected Voices. In today's HotSpot 10 episode, we have Suketu, who is Ventiv's product line manager for DAS antennas and passives. In today's episode, we will be talking all things DAS. Thanks for joining us, Suketu.
Thanks for having me, Jonathan.
So, yeah, of course. So tell us, Suketu, what is DAS?
Sure. So DAS, or Distributed Antenna System, is a network of antennas across the building, mainly to extend and provide seamless cellular connectivity in small to large facilities and public venues. Right? So signal from donor macro site or from on-site station, base station is brought in and then amplified and distributed across the building using active and passive components. The reason those are called active components are because they require power source to operate, and they typically include head-end units, BDA or bidirectional amplifiers, or sometimes called repeaters, remote radio units, RRU, and so on. Whereas on the passive side, you have antennas, splitters, steppers, diplexers, coax cables, and jumpers, etc.
So what are the different types of DAS then?
Yeah, great. So there are mainly three type of DAS out there: active, passive, and then hybrid, which is combination of active and passive. So passive DAS is the most basic and low in cost when compared to active DAS. Architecture is very, very simple and relatively easy to install. The reason why it's called passive is because they use the passive devices to distribute signals across the building. They're mainly ideal for small to medium-sized buildings, and you commonly see those DAS deployments, passive DAS deployments in public safety. On the other hand, active DAS is really high in cost and usually complex to install, right? It uses active devices and fiber distribution, right? So fiber is something new in active, right? Which is not the case with passive. And they use fiber to overcome losses in uplink and downlink, right? Which are very inherent in passive DAS. Typically, what happens is our RF signal is digitized and travel, long distances over fiber optics to RRU or remote radio unit, where it is converted back into coax or RF and distributed over the coax to the antennas. Offers great level of flexibility, ease of zoning, and this all makes active DAS an ideal solution where capacity and coverage are needed. You typically see active DAS in airports, stadiums, and arenas, hospitals, campuses, high-rise buildings, and so on. And finally, hybrid DAS, like I said, which is combination of active and passive element. And I often use in medium-sized building with a special geometry and features where passive system is deployed in one part of the building and active on the another. The one key thing to remember when we talk about DAS is DAS as distributed antenna system, as name suggests, distributes the signal. It does not generate the signal itself. And what that means is it does not add new capacity, but rather use the available capacity.
Oh, thank you, Suketu, for going through those. So, my next question, that I have is, why can't the outdoor macro network be used instead of DAS?
Yeah, I think it's a great question, right? And the short answer is capacity and coverage. So if you think of, all these buildings, right, they are made of bricks and concretes and metal, glass, windows, and so forth, so on, right? And all these materials block RF signal. So by the time your signal made into the building, your signal is significantly attenuated or weakened. And so that's not something ideal for having connectivity within in building. So you run into, and I'm pretty sure everyone runs into these scenarios where you have strong signal outside the building, but as soon as you get in the building, your signal quality is very poor. And that's because there are a lot of nowadays there are a lot of buildings are LEED certified or energy efficient buildings, what they call it, and these buildings uses low E or low emissivity glass windows. So if you go into these big metro cities, with big high risers, and there are all glass buildings. And all these glass windows are low E or low emissivity windows, right? And they have a very thin metal layer of metal coating that not only rejects the UV and solar heat for energy efficiency, but then they also create significant barrier for RF signals. So for example, just to give you, a data point, if you have a double glazed low E glass window, the low band 900 megahertz signal is attenuated by about 30 dB. That is about 99% reduction in signal strength. You know that in RF, every 3 dB your signal power halves. So think about that. That's a significant loss in signal power level. And when we talk about the large public venues such as stadiums, when the event's happening, you do not want to rely on nearby macro towers, as they will you quickly overwhelm them. So for those, you really need high capacity DAS to tackle that. And talking according to some estimations, about 80% of data traffic and over 60% of cellular calls originates from within the building. So you got to have a robust and reliable in-building connectivity.
Well, thanks, Suketu. I appreciate you going through that. So the next question I have is, what are the key design considerations in DAS?
So whether you're designing most basic single band in-building system or complex multi-band multi-operator systems, there are certain things, almost all building owners and service providers need to consider, including understanding the required minimum RSSI, which is receive signal strength indicator per technology. You need to understand how many operators and technologies support and how many carriers on the systems. Are there going to be future expansions to the facility, which will require DAS connectivity in building connectivity? Identifying equipment partners and vendors, understanding link budget and which technology has the smallest link budget and coverage range, other physical constraints that building might have. So these are all some good design considerations one should keep in mind.
Well, thanks. How can Ventiv help?
Sure. So Ventiv offers high quality, high performance antennas and passive accessories. Our portfolio includes low PIM indoor and outdoor antennas in SISO and MIMO varieties. We have a high quality tapers, splitters, and cables, and we do all kind of custom jumper assemblies. We believe in partnering with our DAS customers and offering our competitive portfolio, and we work very closely in meeting their needs and schedules. Also, our portfolio is available in IB Wave and Atoll in-building component libraries. So customer can design in system using our components. And not to mention our top-notch sales, always eager to help with your projects and needs.
Yeah, and you can find this information at ventivinfra.com, or you can reach out directly to an RSC, as Suketu mentioned, at sales@ventiv.com. Well, Suketu, I appreciate your time today, and thank you for coming on.